Hi class, so we're going to talk about eclipses and lunar phases. So first, why does the moon look different every night? From night to night it looks different. It's small, it looks like it's less illuminated, then it gets more and more illuminated, then eventually it gets full. We're all familiar with the full moon, and then it gets less and less illuminated again. And so why is that? And then also what causes eclipses, lunar eclipses and solar eclipses. So a lot of people think that the moon, well, I don't know about a lot of people, but many people I've heard think that the moon goes through these phases, these different sort of shaded sort of times where it's partly shaded, very bright, and then partly shaded again, because somehow Earth is casting a shadow on it all the time. Well, the Earth does cast a shadow on the moon, but that's only during a lunar eclipse, and that's always when the moon is full, as we'll see. So why does the moon do this? Why does the moon sometimes appear half of a moon, a crescent moon, other phases in between? So the first thing we need to understand is what the moon is doing. It's orbiting the Earth. So this thick line is the Earth's orbit around the sun, and while the Earth is going around the sun, the moon goes around the Earth. And the moon is pretty small. This is a fairly decent diagram showing like the relative sizes. The Earth is small, of course, the moon's even smaller, and there's a pretty big distance between the Earth and the moon. And the moon goes around the Earth, and it takes about 27 and a third days for the moon to go around the Earth once relative to the distant stars. But while this is happening, while the moon is going around the Earth once, the Earth is moving around the sun. So, what's going on with the shading of the moon? If we look at this picture down here, we're seeing the moon here and the Earth here. Both of them are illuminated by the sun, so this would be the Earth. Half of the Earth is illuminated. This would be the daytime side. And if you look at the moon over here, we see half of the moon is illuminated as well. And so no matter where the moon is around the Earth, you're always going to find half of the Earth illuminated and half of the moon illuminated. So there's always one side of the moon that's always lit up. And the phases that we find, that we see, come from the fact that as the moon goes around the Earth, from the Earth we see different parts of that illuminated side. We don't always see the whole illuminated side. So in this position right here, if you were on the Earth, anywhere on the Earth, looking toward the moon, you would see it during the daytime. You could certainly see it during the daytime, but if you're looking in this direction toward the moon, you're going to see mostly the dark side of the moon, the darkened side. Not the dark side as in the back side, but the side that it's currently dark. You might see a little bit of this part up here that's a little bit illuminated. You might see a little crescent moon in this case. And then as the moon goes around the sun some more, in this position where the moon is located right now, as long as the Earth isn't blocking the light from the sun, you'll see the fully illuminated side of the moon. You'll actually see a full moon because the moon is opposite the sun. So let's look at those diagrams a little bit more clearly. This is a person holding up a ball, and imagine that the sun is off in this direction over here. Clearly, if the sun is over here somewhere and it's shining light this way, and she's holding this ball and that's representing the moon, well, it's certainly possible that that ball could be blocking the sun from her view. That would be a solar eclipse. That would be an eclipse where the moon is blocking the sun. That doesn't happen every time. The moon goes sort of in front of the Earth. The Earth is sort of her head. But as we'll see, there's a reason for that. But when it does, when the moon does block the sun, that is a solar eclipse. But it usually doesn't block the sun. But, there's always a time, about once a month, where the moon is roughly between the sun and the Earth. And when it's in that position, we don't see at any of the illuminated side of the moon. The entire illuminated side of the moon is opposite from the Earth side. We see the dark side over here. And so we don't see anything. And this would be during the day, and we just don't see the moon. And so it looks like you don't see anything there. The moon is there. The lit up side just isn't facing us. And so this is called a new moon. We just don't see it. And throughout the course of the day, it moves right along with the sun. It's in the same part of the sky as the sun, so it rises and it sets with the sun. And then as time goes by, the moon goes around the Earth this way. And so when the moon gets to a position over here, let's say this position right here, if you imagine taking her head and looking toward the moon, looking in this direction toward this moon, you would see this side of the moon illuminated. You'd see the right side of the moon illuminated and the left side dark. This is an actual picture of that moon. Here's the right side, if we're looking at this picture now, here's the right side of the moon illuminated and the left side is dark. That's called a first quarter moon because the moon has gone 1/4 of the way around its orbit from new moon. It's the first quarter of its orbit. That's a first quarter moon. Some people call it a half moon. It's really not technically called a half moon. It's called a first quarter moon. And it rises at about noon. The sun rises at roughly 6 a.m. or so, and this moon will rise about 6 hours later, roughly. And then throughout the next few days, the moon is going to go from this position to this position, and then eventually to this position. But when it's in between the first quarter and this position, we're gradually seeing more and more of the lit up side of the moon as the moon comes around. And so we see this, we see more lit up side, and that's called the waxing gibbous. Gibbous meaning that it's more than a quarter. Waxing means that we're adding more and more light to the moon as it's going around. Eventually it becomes a full moon. The full moon is when the moon is opposite in the sky from the sun. And yeah, sometimes the shadow of the earth could block the sunlight from hitting the moon, and that's when we get a lunar eclipse. But most of the time, the light does not get blocked, as we'll understand why that is shortly. But when we see the moon opposite in the sky from the sun, we see its fully illuminated side. So it looks like a full circular moon. And it's opposite in the sky from the sun, so it does the opposite things. It rises when the sun sets, and it's highest in the sky at midnight, roughly, and it sets when the sun rises. So it does the opposite things that the sun does. And then as time continues to go on, the moon goes from full moon to over here, and we gradually start to see less and less light now. We start to see some darkening. The lit up side we're still seeing most of the lit up side, but there's a little bit of the lit up side that we don't see anymore. So this is again a gibbous phase because it's mostly lit up, not completely, but mostly lit up. But it's waning, meaning that it's decreasing in lit upness, if you will. And so it rises late in the evening after sunset, and it sets in the mid-morning. And then as the moon continues to go around, there's going to be another phase where it looks half lit up. If you can look right in here under her ponytail, you can see that the left side of the moon would be lit up, the right side would be dark. And that's what the picture looks like. The left side is lit up, the right side is dark. We see another quarter phase, not a half moon, but called a quarter phase. And that's the third quarter. The moon has gone 3/4 of the way around its orbit, around the Earth. And then finally the moon eventually comes back to this position where it's a new moon again. And in between that, we are seeing less and less light on the moon. We see a little crescent moon eventually. It's called a waning crescent. Waning meaning again that the light is decreasing on the moon. And we eventually don't see the moon at all, and we again get a new moon. Now, we had said that it takes the moon 27 1/3 days to go around the Earth once, and that's true, but remember that while this is happening, the Earth is going around the sun. So it actually takes a little bit longer to go from new moon around to become another new moon, because we have to line up again with the sun, at least roughly, approximately, again, not directly in the way, but maybe a little bit above or below the sunlight. And so that extra little time is about a day and a half, roughly. And so it actually takes 29 1/2 days to go from new moon to new moon because of the Earth going around the sun during that motion of the moon going around the Earth. So new moon to new moon is called the synodic period. It's about 29 1/2 days. And that's where the month comes from. The month comes from the cycle of lunar phases, which is about 30 days long. So these are the phases that we've talked about. New moon, crescent phase, first quarter, and gibbous. So these would be waxing crescent, waxing gibbous. Light is increasing on the moon, and then we get to a full moon. These are all moons that are visible in the afternoon or evening, and the moon is getting more and more full, and it rises later and later every day. And then after full moon, we're losing light. And so the full moon rises when the sun sets. And so this gibbous phase rises after sunset and even further after sunset for these other phases. These moons are getting less and less full, and they set later and later every day. So if you think about this question, say it's 9 a.m., it's during the morning, it's in the morning, it's light out, you can't see the stars, the sun is in the sky. At about 9 a.m., the sun is roughly between the eastern horizon and the southern meridian. So it's not quite noon yet. The sun hasn't risen all the way up, but it's about halfway from morning, from sunrise to noon, roughly. And you look up in the sky and you see a moon with half its face bright and half dark. So half being bright and half being dark tells you it's a quarter phase, but which is it, first quarter or third quarter? If you think about which moon can be seen during the day, and think about the positioning of the moons, you should or the different phases where the moon is in the different phases, you should realize that the third quarter moon is a moon that is kind of getting closer and closer to the sun, and it can be seen during the day. If you look at the sun, that third quarter moon would be to the right of the sun, about 90 degrees in terms of an angle to the right of the sun. So the third quarter moon would be a moon that you could see about 9 a.m. in the sky, and that phase would be, if the sun is to the east, to southeast, that phase would be located in the southwest, about 90 degrees over. Here's another picture, kind of another sort of simulation that you can do. You might ask, why can you see the same side of the moon all the time? Why do we see always that same side? There is a back side of the moon that we don't see from the Earth. Some people call it the dark side of the moon, but it really isn't always dark. It's actually just as lit up as the side that we see. It goes through these cycles. The reason why we always see the same face is because of something called tidal locking. Over time, the moon used to rotate faster, but over time the gravitational pull of the Earth has caused the moon's rotation to slow down, and the moon still does rotate, but it faces, the same side always faces the Earth. If this is the Earth here, as this is a person kind of rotating, you just imagine that this person is going around the Earth, and they're doing it in such a way to always be facing the Earth. In order to do that, they actually have to rotate. You can see that that person starts off in this position, and as they go around, they have to rotate once in order to always be facing the Earth as they go around the Earth once. So the moon does rotate, and in fact it rotates once on its axis for every time that it goes around the Earth. This is called synchronous rotation, and it's because of the effects of gravity pulling on the moon from the Earth. So eclipses, we'll talk about both solar and lunar eclipses, and if you think about the fact that the Earth is a pretty big object, the moon is smaller, but regardless, the Earth can block some sunlight. And so if you've got this big ball of light here, shining light in all directions, specifically toward the Earth, and if you were to look behind the Earth, you would see a shadow. There's a very dark part of the Earth's shadow. It's called the umbra. And if you were anywhere in this shadow, you would not be able to see the sun at all. It would be completely blocked by the Earth. But there's another part of the shadow. Because the sun is not a little tiny point dot of light, it's a ball of light. There are places in the Earth's shadow where you can see some of the sun. Not all of the sun is blocked, but some of the sun is blocked. So that is still part of the shadow. You're not getting the full sunlight hitting you, but there's still a lot of sunlight hitting you if you're in this region. That's called the penumbra. It's the not quite so dark part of the Earth's shadow. And then somewhere over here, you'd see the entire sun. The entire sun none of the sun would be blocked by the Earth. So there's these two parts of the Earth's shadow. The umbra, the darkest part, and the penumbra, the lighter part. And if you were to cast those shadows onto a big sheet of cardboard or something, huge, monstrous sheet of cardboard out in space, you would see a really tiny dark dot, depending on how far away you were from the Earth. And around that, you'd see a kind of a shaded disk. And then around that, you'd see fully illuminated sunlight on the cardboard. But that'd have to be a pretty big piece of cardboard. So now imagine that the moon goes around the Earth, and sometimes the moon can pass through the shadow. Most of the time the moon doesn't pass through the shadow at all. It passes above the shadow or below the shadow. But sometimes it passes through the shadow. Sometimes it passes through the darkest part of the shadow. And that's how we get a total lunar eclipse. So here are 3 different eclipses. Sometimes the moon passes entirely inside the shadow, and the part of the shadow it passes through is bigger than the moon itself. So the entire moon can be blocked, the light from the sun can be entirely blocked from the moon. But you can still see the moon, even though no sunlight is directly hitting it. It's being completely blocked by the Earth. So why can we still see some of the moon? Well, the reason is because the Earth has an atmosphere, and sunlight doesn't just go straight across the Earth. It actually bends as it goes through the atmosphere, and red light bends better than blue light. Blue light and such and green and things get kind of scattered off in different directions. The red light is able to bend a little bit better, and so some light does get through the atmosphere and bends toward the moon. And so you see a moon that is still lit up. It's darker than it was before, but it's still kind of lit up, and it looks red. And sometimes they call that the blood moon. It's red simply because it's really, it's red light that's hitting the moon, because that's the kind of light that can get around the Earth. It bends around the Earth. If you were on the moon looking back toward the Earth during an eclipse like this, you'd see a red ring. You'd see like a sunset type red ring all the way around the Earth. You'd see like sunset all the way around the Earth, because that's what it looks like at sunset when the sun is really low on the horizon. It looks very red because it's that red light that's able to get through. If the moon doesn't pass all the way through that shadow, but partly through that dark part of the shadow, you see a partial solar eclipse. So you see a fairly dark area here and a almost normally lit bright area up here. And why doesn't this look red down here? Well, it would look red if you could block out the brilliant light from here, but there's a lot of light being reflected off of the moon up here. It is pretty bright. And so the red that is hitting down here is there, but it's just harder to see because of the contrast between the bright part up here and the darker part down here. This is a partial lunar eclipse. And then you could have a penumbral eclipse, where the eclipse does not at all pass through the dark part of the shadow. It passes through this lighter part of the shadow, and it's hard to tell that anything's going on. These happen pretty frequently, and it's hard. You look up at the moon, and you wouldn't really notice it unless you knew what was going on. You wouldn't really notice that this kind of an eclipse was happening. This is pretty frequent. So those are the three main types of lunar eclipses: the total lunar eclipse, the partial lunar eclipse, and the penumbral eclipse. And then when can they occur? They can only, of course, occur at a full moon. The moon has to be full. It has to be on the opposite side of the sun from the Earth. And then you get these three different eclipses. A lunar eclipse will not happen at any other phase, quarter phase, anything. It has to be a full moon. Most of the time when there's a full moon, though, the moon passes below or above these two shadows. And again, sometimes it passes through the lighter part of the shadow, and we just don't know that anything's going on. That's the penumbral eclipse. Now, solar eclipses are similar. In solar eclipses, we're looking at the moon's shadow. And the moon blocks sunlight, too. The moon has a dark part of the shadow and a lighter part of the shadow. And it's when that shadow hits the Earth that we see a solar eclipse. So this is an actual picture from space of the dark part of the moon's shadow hitting the Earth. And as time goes on, because of the Earth's rotation and also because of the moon moving around the Earth, this part of the shadow is traveling across the Earth, and it could travel like 1,000 miles an hour because of the Earth's rotation and the moon going around, the motion of the moon around the Earth. The shadow is actually traveling. And so if you're in the path of this shadow, you'll literally look how dark it is in here. You'll literally feel as if it's becoming nighttime for a very small amount of time. So you have to be in a very specific place on the Earth to see a solar eclipse. If you were up here somewhere, you wouldn't see it. If you were down here somewhere, you wouldn't see it. You might see a partial eclipse. You might see something like this, where the moon is partly blocking the sun. But you wouldn't see this, which is pretty incredible, where the moon is completely blocking the sun. The moon has an orbit that isn't perfectly circular, and sometimes it's further away. So it doesn't completely block the sun. So it leaves like a ring of sunlight around it, and that's called an annular solar eclipse. It's not total because it's not completely blocking the sun, but the moon looks a little bit smaller in size than normal, and that's simply because it's a little bit further away because of it's where it is in its orbit, and it doesn't completely block the sun. We get an annular eclipse. So these are the different types of solar eclipses. Partial solar eclipses are somewhat common. Total solar eclipses are very hard to find. You have to be in the right place. You have to be in the path of totality, right? And that shadow has to travel over your location. These annular eclipses are also difficult. They're also rare. You also have to be in the path. But in the annular eclipse, this dark part of the shadow doesn't reach the Earth, but you still have to be in the right position on the Earth, kind of below where that shadow would reach, if it were to reach the Earth. You still have to be in the right place to see this nice annulus, this nice ring of fire around the Earth, around the moon, I mean. So solar eclipses are much more rare, mainly because you have to be in the right place to see them. Lunar eclipses are very common. If we go back to the lunar eclipses, if you're on the Earth and there is a lunar eclipse like this one, anywhere you're on the Earth, the dark side of the Earth, any place that you're at and you can see the moon, you can see the eclipse. It doesn't matter where you are. The timing of the eclipse may affect whether you can see it or not. But if you can see the moon, you can see the eclipse. Whereas the solar eclipses, you have to be in the path of the shadow to actually see the solar eclipse. One other factor that's interesting is that we talked about why we don't get an eclipse at every full moon and new moon. Again, the new moon is when the solar eclipses happen. It's because the moon's orbit is actually tilted. The moon orbits around the Earth, and that orbital plane is actually tilted. All right, if you think about the plane of orbit of the Earth around the sun, and then there's a plane of orbit of the moon around the Earth, sometimes the moon orbits above the Earth's orbital plane, and sometimes it orbits below. So the moon has to be directly between the Earth and the sun for a solar eclipse. The moon has to be directly behind the Earth relative to the sun for a lunar eclipse. But many times, most times in fact, the moon is above the shadow of the Earth, or the Earth is sort of above or below the shadow of the moon. Things don't line up perfectly because of the tilt of the moon's orbit. So these places where the moon's orbit crosses the Earth's orbital plane we call nodes, and the moon has to be near one of those nodes. There's a node here, there's a node back here. If the moon is near one of those nodes, you'll most likely get an eclipse. And most likely you'll get a lunar eclipse if the moon is a full moon, because the Earth's shadow is fairly big, and it's fairly easy for the moon to go through the shadow. Whereas things have to be lined up really precisely for the shadow of the moon to pass over the Earth. So lunar eclipses are much more common because the moon can fit inside that shadow much more easily than the shadow of the moon falling onto the Earth. So the moon must be a full moon for lunar eclipses or a new moon for solar eclipses, and the moon must be at or near one of the 2 points in its orbit where it crosses the ecliptic plane, the Earth's orbital plane, and those points are called nodes. And then one last thing, we're not going to talk about too much why this is, but because of this tilt of the moon's orbit, and actually the fact that that orbit kind of wobbles, that orbital plane kind of wobbles over time, that leads to a cycle of eclipses that have about an 18-year, 11 and a third day sort of cycle. It's called the Saros cycle. This was observed for years, hundreds and thousands of years before we knew what was going on with eclipses, why they occurred. Ancient people observed eclipses, recorded them. They saw this pattern of eclipses. And it's because of these orbital properties of the moon and the Earth going around the sun. And there's this cycle that we now understand. But back then they didn't really know what was going on. So if you look at these eclipses, for example, this one in 2034 around March 20th, there's a related one, 2016, March 9th. You can see kind of the shape of that. This is a solar eclipse, the shape of that path of totality across Africa and Asia, Europe, the Middle East, and so on. There's a related one, 2016. It's about 18 years apart from March 20th to March 9th, from 2016, March 9th to 2034, March 20th. So that's part of this cycle of eclipses. And there's one down here. This one and this one are related. And these are the paths of totality. There's one interesting one here. August 21st, 2017. So that's going to be a good one to watch out for. August 21st, 2017, there'll be a total solar eclipse, and you'll be able to see it across the United States. So hopefully you'll be able to see that. So let's just look at a couple quick little animation things. Again, we have the study area in the Mastering Astronomy site, and this is a good one. It's just kind of shows sort of an animation of somebody holding up a ball in front of them, And here's the sun. Imagine this is the sun, and this person's holding up this ball and making it kind of orbit around them while they watch it. And so they're watching this ball that's being illuminated by the sun, and we're going to come in here and try to see this from this person's perspective. As this ball goes around their head, we see a full moon, full phase, right there. And now we see waning gibbous, third quarter, waning crescent, and there's a new moon, waxing crescent, first quarter, waxing gibbous, full moon again. So you see how the moon, or this ball, is changing phase as it orbits around our head, and there's a source of light in the distance that we might call the sun. So then we've got these other ones. There's lunar eclipses, little animation for lunar eclipses here, and this is good. It just shows some different configurations. So what you can do is you can click on one of these eclipses, put yourself somewhere on the Earth, and it'll show you what you would see. So this is a moon that is not in either part of the shadow of the Earth here. And when we look at it from this location on the Earth, we see it as a normal moon. It looks like a normal full moon. If the moon is completely, let's do a partial one. Let's put the moon in there, and let's put ourselves on the Earth. This is what the moon looks like. It looks like a partial lunar eclipse. This part of the moon down here is in the Earth's shadow, and this part is not in the Earth's shadow. And as the moon orbits the Earth, more and more of the moon will go into the shadow, but you might not see the entire moon inside the shadow. So here's a total. Let's put ourselves somewhere on the moon, on the Earth. And here's a total lunar eclipse where we see the moon completely dark, but still kind of bright. Not as bright as a full moon normally is, but it's only bright because of that red light that can get through. It can kind of sneak around the Earth and cause like a sort of like a sunrise, sunset kind of color to the moon. And here's a penumbral eclipse. And again, it looks almost the same as a total or a full moon, but it's a little dimmer. And you know, with your naked eye, you might not notice any difference between a penumbral eclipse and a lunar or a full moon. They're fairly similar in brightness. But if you were to measure it with something kind of that could measure brightnesses fairly precisely, you would notice a difference. But our eyes might not be able to distinguish the two. So hopefully this helps understand some things. This last one is a nice little video showing the shadow of the moon moving across the Earth. This view is our view from the Earth. We're looking at the sun during the day, and here we are located in Africa or South America, it looks like. And there's the shadow of the moon. The shadow is being cast onto the Earth. Anywhere in that darkest part of the shadow, we would see the moon completely covering the sun, and we'd see a total solar eclipse. Anywhere in this region, we would see a darker, it's a darker, not the darkest part of the shadow, but it's still part of the shadow. We'd see a partial solar eclipse. So if we play this, we let the sun go through there, and we pause for a second, the shadow is just coming over us, and we can see that now the sun is getting blocked almost completely by the moon. Go forward just a little bit. There we go. Now the moon is completely blocking the sun, and we can see this isn't like glare. This is not glare coming from the brightness of the sun. This is in fact the outer atmosphere of the sun. This is the only time you can directly see the outer atmosphere of the sun, is when the main part of the sun is being blocked. So this is it's really, if you have an opportunity to see a solar eclipse, total solar eclipse, you know, do whatever you can to see it. And then this might only last like a minute and a half, this totality, because the shadow is traveling across the Earth at about 1,000 miles an hour. It depends, but it's traveling very quickly. And so as time goes by, the shadow moves. We see a partial eclipse for a while as we leave the sort of the bigger, not quite as dark part of the shadow, and eventually the moon is has completely uncovered the sun, and we see the sun as we did before. And the moon is somewhere over here, but we don't see it because we don't see any part of the illuminated side of the moon. So those are solar eclipses, lunar eclipses, phases of the moon. So hopefully this helps understand some of those things. Again, I encourage you to play with these animations, play with these figures, and send me an email anytime you have any questions. Have a good night.